Okay, Assalamualaikum and good day everyone. So today we are going to start with the second lecture of chapter 2, which is the absolute values, the subtopic of 2.2. So at the end of the lesson, students should be able to state the properties of absolute values, solve absolute equation, solve absolute inequalities. Okay, so let's start. Okay, so what is absolute value? Absolute value describe the distance from zero that a number is on the number line with considering direction. So the absolute value of a number is never negative, okay? For example, 6 is 6 away from 0 and negative 6 also is 6 away from 0. So the absolute values of 6 is 6 and absolute of negative 6 also 6. So both have the same unit, which is 6 units. One from the right to the right side, another one to the left hand side. Okay. The absolute value can be defined as absolute A is equal to A. If A is more than or equal to 0, means that it's a positive value. Or negative A if A is less than 0, which is negative. So if A is negative, a negative value multiplied with a negative sign, we will get a positive value. That's why it always positive. Absolute value always positive. So negative multiplied with negative is positive. Okay. Also, absolute A is equivalent to square root of A squared. So even though A here is a negative value, when you square it, we will get positive value. And then use square root of it, of the number, we'll get a positive value. For example, absolute 7 is equal to square root of 7 squared, which is also equal to absolute negative 7, which is square root of negative 7 square. Both give the value of 7. Properties of absolute value. This one you have to take note and put in your short note for your referral during the exercises. First of all, absolute values A is always more than or equal to 0, means that it always positive. And then absolute A is equal to the absolute of a negative A. And absolute of A plus B is equivalent to absolute of B plus A. And number 4, absolute of A minus B is equal to absolute B minus A. So if B is bigger than A, you will get a negative value here. But because of the absolute notation, you will get positive. Number 5, absolute of AB is equivalent to absolute of A multiplied with absolute of B. Both are positive value. And lastly, absolute of A over B is equivalent to absolute of A divided with absolute of B, where B must not equal to 0. So please take note of these 6 properties of absolute values. We will use it in solving the absolute equation and inequalities. Absolute equation. So absolute equation, absolute x is equal to a, where a is more than 0, represent the distance of x from the origin is equal to a units on the number line. So let's say this is negative a and this is a, both on the left hand side and right side of 0. So this is x. X is equivalent to absolute of x is equivalent to either a or negative a. Therefore, absolute x is equivalent to x equal to a or x equal to negative a. So if we have absolute at a certain variable, then if we define it by to eliminate the absolute notation, we can define as x equal to a, or x also can be equal to negative a. We are talking about the distance only, the magnitude, not the direction. Okay, so this is what we call as the definition of absolute equation. So absolute of x equal to a can be defined as x equal to a or x equal to negative a. So you have to take note this definition of absolute equation. So let's do some example. So solve the following equation for a, absolute x equal to 7. So what is x? X can take a value of what? So we can use the definition of absolute equation, means that x can be equal to 7 or x can be negative 7. Okay, so how about b? So the answer you can write down in the solution set lah. So such that x equal to negative 7, 7 or 7. For question b, absolute x plus 8 equal to 2. So by using the definition of absolute equation, we can write down as x plus 8 equal to 2 or x plus 8 equal to negative 2. So what is our answer for x? X either negative 6 or x equal to negative 10. So write down in the solution set. So x such that x equal to negative 10 or negative 6. So our target is to find the value of x as usual for equation. So let's do example 2. Solve a, absolute x plus 4 equal to 5x plus 8. And b, absolute 2x plus 3 equal to 3x plus 2. So for a, absolute x plus 4 equal to 5x plus 8. So we use the definition of absolute equation. We will write down the one inside the bracket as on the left hand side as an x. So it will be x plus 4 on the left hand side equal to 5x plus 8. Or everything on the right hand side will be negative. So or x plus 4 equal to a negative of 5x plus 8. Now we just have to let x as the subject to solve the linear equation. So bring the 5x to the left hand side for the first equation here. So we get x minus 5x, or we can bring x to the right hand side, whichever you want lah. So if you bring x to the right hand side, you get 4x here. And then 4 minus 8 will be negative 4. Yes. Or you can also write down x minus 5x, we get negative 4x equal to 8 minus 4 equal to 4. So x is equal to negative 1. So you get the same answer in whichever the way you do. As long as you let x as the subject at the end. Okay, so we have x equal to negative 1 for the first part of the definition. And the second part of the definition, we have x plus 4 equal to negative 5x minus 8. So expand this, we will get negative 5x minus 8. So let x has the subject, so you can bring the negative 5x to the left hand side. We get x minus 5x plus 5x, which is equal to 6x. And negative 8 minus 4, we get negative 12. So x is equal to negative 2. So negative 2 and negative 1 both will be the answer for the absolute equation. Okay, so check. So we have to check whether the answer will satisfy the question or not. So we let x equal to negative 1 and sub on the left hand side of the equation. We get absolute of negative 1 plus 4. And the right hand side we get 5 multiplied by negative 1 plus 8. So the left hand side we get, this is equivalent to 3. So the answer is 3 here. And here is negative 5 plus 8, which is equal to 3. So both are equivalent to 3. So the left hand side is equal to right hand side, so it's true. So we can accept for x equal to -1. How about x equal to -2? So on the left hand side we get -2 plus 4, which is equal to 2. And the right hand side we get 5 multiplied by -2 is -10 plus 8 is equal to -2. So now we have 2 on the left hand side and -2 on the right hand side. It's not the same value. Okay, so can we accept x equal to -2 as the answer? No. So what you need to do, the final answer should be only x equal to -1. So remember, always remember, for the absolute equation, you have to check every time you found out the answers. So let's do question B. Okay, so for question B, absolute 2x plus 3 equal to 3x plus 2. So using the definition of absolute equation, we have 2x plus 3 equal to positive of 3x plus 2, or 2x plus 3 equal to a negative of 3x plus 2. So we solve for the left hand side first. So after you bring the x to the left hand side, or let the x as the subject on the left hand side, you will have x equal to 1. And the right hand side, after you expand this, we get -3x minus 2. So the left hand side we get 5x, the right hand side we get -5. So x equal to -1. So as the same question number A, we need to check. Okay, put the x equal to 1 into the question bag. So the question bag is here. Okay, so the left hand side is 2 multiplied by 1 plus 3 absolute equal to 3 multiplied by 1 plus 2. So we get 5 on the left hand side and 5 also on the right hand side. For the x equal to -1, so we get put into the question bag. So we have absolute of 2 multiplied by -1 plus 3. So here we get -2 plus 3, which is equal to 1. Right? So absolute of 1 is still 1, and the right hand side we get -3 plus 2, which is equal to -1. So both are not the same value. One is positive, another one is negative. So we have to reject the answer for x equal to -1. So the final answer for question B is equal to 1 only. So the solution set of x such that x equal to 1. Okay. Okay, so let's try to solve the next example. Solve the following equations. Okay, so for question A, absolute of x plus 4 equal to absolute of 5x plus 8. And question B, absolute of 2x plus 3 equal to absolute of 3x plus 2. So for question A, so what you need to do, we just have to define as usual, even though we have two absolute sign here. So what we will get is, first equation is x plus 4 equal to 5x plus 8, or x plus 4 equal to the negative of 5x plus 8. And then we solve as usual, we get x equal to -1 and x equal to -2. For this one, we try to check by substituting the value of x into the question bag. Okay, so when x equal to -1, so what do we get here? We get -1 plus 4 absolute, and then on the right hand side also absolute of 5 multiplied by -1 plus 8. So we have absolute 3 on the left hand side and absolute of 3 on the right hand side, which is both are equal to 3. When x equal to -2, so what do we get here? We have absolute of -2 plus 4, and the right hand side we have absolute of 5 multiplied by -2 plus 8. So the left hand side we get 2, the right hand side we get -2. But because we have absolute on both sides, what we get is 2 on the left and right. So it is the same. It satisfies the question. So we can take both value as the answer. So the final answer, the solution set is such that x equal to -2 and -1. Okay. For question B, absolute of 2x plus 3 equal to absolute of 3x plus 2. So as usual, we define it by using the definition of absolute equation. We have 2x plus 3 equal to positive of 3x plus 2, or 2x plus 3 equal to the negative of 3x plus 2. So solve for the x, so we get negative x equal to negative 1, so x equal to 1. And here after expand, we get negative 3x minus 2, so 5x equal to negative 5, so x equal to negative 1. And then don't forget to check. So when x equal to 1, we sub x into the question. So we have 2 multiplied by 1 plus 3 absolute equal to absolute of 3x, 3 multiplied by 1 plus 2. So we get both equal to 5. And when x equal to negative 1, we have absolute of 2 multiplied by negative 1 plus 3. So we get 1 here, and equal to absolute of 3 multiplied by negative 1 plus 2. So we have negative 3 plus 2 equal to negative 1. So absolute of 1 is equal to 1. Absolute of negative 1 is equal to 1. So both are the same. So we can accept both answer for this question. So our x is equal to negative 1 or 1. So example 4. Solve the following equation. So the first question is absolute x squared minus 25 equal to 0. And question B is absolute of x squared minus 7x plus 6 equal to 6. So let's do question A. So we have absolute of x squared minus 25. By definition, we will get x squared minus 25 equal to 0. And then if you use the definition, we get x squared minus 25 equal to negative 0, which is equal to 0. So we can just ignore this. So we get x squared minus 25 equal to 0. So solve for the x. This is a quadratic equation. So we can factorize. So factorize, we get x equal to 5, x equal to negative 5. Do we need to check? No need, because this is a positive value. Always true lah. This is a positive part. Okay, so let's do question B. So absolute of x squared minus 7x plus 6 equal to 6. So by using the definition, what do we get? We will get x squared minus 7x plus 6 equal to 6, or x squared minus 7x plus 6 equal to a negative of 6. The question A, we have 0, so we don't have to take the negative 0 because it will be the same. Nah? For this one, because we have a value on the right side, we have to put the negative on this. So solve for the left hand side first. We get x squared minus 7x equal to 0. So x equal to 0 and x equal to 7. And the right side, we get x squared minus 7x plus 12 equal to 0. And solve for the x, we get x minus 4, x minus 3 equal to 0. So x equal to 4 and x equal to 3. So we need to check, right? Because we have two equation here. Okay, so let's say we solve for 0. 0, we sub back 0 minus 0 plus 6, positive 6 equal to 6. And 3 squared 9 minus 21 plus 6. 9 minus 21 plus 6. 3 squared, right? 3 is equal to 3 squared minus 7 multiplied by 3 plus 6, which is equal to 9 minus 21 is equal to negative 18 plus 6 is negative 9 minus 21 is equal to, sorry, use your calculator. 9 minus 21 is negative 12. Negative 12 plus 6 is negative 6. So absolute of negative 6 is equal to 6. Okay, how about 4? So 4 squared is equal to 16 minus 7 multiplied by 4 plus 6. So we get, this is negative 28. So 16 minus 28 is equal to 2. minus 12 plus 6 is negative 6 absolute. So we get 6 also. And 7, 49 minus 49 plus 6. So we get 6. So all are accepted. Nah? Okay. Absolute inequalities. This is the last learning outcome for this subtopic. So earlier we have absolute equation, now we have inequalities. So what we need to do, we have to combine the definition of absolute with the inequalities we learned in subtopic 2.1. So absolute inequalities, we can have absolute of x less than a, means that x should be in between negative a and a. Okay. Or it also can be written as x more than negative a and x less than a. So both should happen together, means that this is talking about the intersection. Okay. So how do we get this inequality? Okay. So x should be, the value of x should be less than a. Means that x, usually I will define it x less than a, and x also should be more than negative a. Opposite sign, opposite direction, opposite sign. So because it's less, we use the intersection form. So this is the definition. Okay, so we use this, the one in the box, to find the answer for x. And then the second one is absolute x less than or equal to a. So it will be the same. The difference only the sign here. So it will be less than, equal to. So the definition, it will be x more than or equal to negative a and x less than or equal to a. So notice here the value of x should be in between negative of a and positive of a. So for this one, for the second one, we have the dense dot here and circle on the first inequality. Okay, so the third expression for absolute inequalities is absolute of x more than a. So for me, if it's a more, then what I will do, I will follow the question, which is x should be more than a. And then because it's more, then the operation should be or. So here will be or. And another definition you should write down is x should be the opposite direction. This is more, it should be less than. This is positive a, it will be negative a. So this is the definition you have to remember for absolute x more than a. Okay, so how to write down this on the number line? So one will be the left side of the negative a, another one should be more than positive a. For b, we get absolute of x more than or equal to a. So to define it, we have the same as the above three. So we have x, follow the question, we have more than or equal to a. Because it's more, that it should be the operation of or. And then the other one should be x and opposite direction less than or equal to, opposite sign will be negative a. Okay, so this is the definition for number 4. Okay, so what is or? Or is the union. Okay, for n it's an intersection, for or it's a union. So how to sketch on the number line? It will be the dense dot, different from 3 by the dot. So for 3 we have the empty dot or the circle. For number 4 we have dense dot or a dot there. Okay, so that's the definition of absolute inequalities. So what you need to do, just apply the definition depending on the inequalities given. So let's do example 5. Solve each absolute value inequality. So let us try one by one. following the definition given in the previous slides. So for question A, absolute 2x plus 3 is less than 5. So by using the definition, follow the question for the first term. So we have 2x plus 3 less than 5. So because it's less, so it should be intersect with 2x plus 3 and then opposite direction, so it will be more than, opposite sign, so it will be negative 5. So this is the first step that I will do every time I want to answer the absolute inequalities question. Okay? So this is, so you also can use the second definition, which is it will be in between. So this is only true if this value on the right side here is a constant. If we have x here, then we cannot use this definition. So because it's a constant, we can use this definition in between negative a and positive a. So you have two choices if the value on the right side, the one without absolute, is a constant. So if we want to use this definition, we get negative 5 less than 2x plus 3 less than 5. And then you can solve as usual from the inequality exercises we have done. So what you need to do to let x as the subject on the center. So to let the subject x as the subject on the center, we have to eliminate the 3 first. So eliminate the 3 by subtracting 3. So we get minus 3, minus 3, minus 3. So we get negative 8 is, okay, so we get negative 8 is less than 2x and less than 2. Okay, and then after that we have to eliminate 2. How to eliminate 2? We divide by 2. Divide by 2. Divide by 2. So we get negative 4 less than x less than 1. Okay, so for this one you can use this definition because it's just a constant on the right side. Okay, so let's do question B. So the solution set of x such that x is in between negative 4 and 1. Or you can write down the answer in the interval form, which is from negative 4 to 1. Open bracket. For question B, absolute of 5 minus 3x more than or equal to 9. So this is more than. So if it's more than, then what I will always do, 5 minus 3x more than equal to 9. So because it's more, it should be or. Or 5 minus 3x, 5 minus 3x is less than and negative 9. So opposite sign, opposite direction. Okay. So you get 5 minus 3x more than or equal to 9, or 5 minus 3x less than or equal to negative 9, or is equivalent to union. Okay, and we solve on the left side, we get negative 3x more than or equal to negative 4, more than 4, so 3x is less than. Okay, for this step, maybe some of you asking how do we get 3x less than or equal to 4. So the next step I usually do to eliminate the 5, so I subtract 5 on each side, so I get negative 3x is more than or equal to 9 minus 5 is 4. So to eliminate the negative, so what I will do, I multiply with negative 1. When we multiply with negative value, so we get 3x, and the sign also need to change. Okay, so we get 3x is less than or equal to negative 4. Or you can directly multiply with negative 1 over 3 lah. So we divide by 3, negative 3. So we get x is more than negative 4 over 3. Okay. Less than, apa more than, sorry. It should be less than lah. Confusing kan? Okay, sekejap saya padam. Comot. So somehow this part your lecturers maybe you have found that we minus 5 in each side, so we get negative 3x more than or equal to 4, right? And then how do we get negative? So they swap. When we swap, okay, so or not, we just multiply with negative 1, negative 1, so we have 3x is less than negative 4. We just have to change the sign. Okay, we just have to change the sign here. From more than it will be less than, so x should be less than or equal to negative 4 over 3. And for the second inequality, we get 5 minus 3x is less than or equal to negative 9. So minus 5, here we have negative 3x is less than or equal to minus 14. So to eliminate the negative, you can just divide with negative 3. So we will get x is from less than, it will be more than or equal to 14 over 3. So here 3x is more than 14 because they eliminate the negative side first. So if you multiply with negative 1, we will get 3x more than or equal to 14. So here I directly divide by negative 3. So you get x is more than or equal to 14 over 3. So we have to make sure the answer correct by finding the union between the two inequalities. So usually we will have to draw on number line. So we have two value, negative 4 over 3 and 14 over 3. So which one is smaller? Will be the negative value lah. So negative 4 over 3 on the left side, 14 over 3 on the right side, and draw the number line. So we have less than negative 4 over 3 and more than 14 over 3. So the union between these two, we take the two inequality lah. So the answer should be, solution set is x such that x is less than or equal to negative 4 over 3 or x is more than or equal to 14 over 3. Or interval form, you can write down it's from negative infinity up to negative 4 over 3, close bracket, union with, close bracket here 14 over 3 to infinity. Okay, so let's do question C. Absolute 3x plus 1 is less than 2x plus 5. Okay, so here you know it's less than. So can we just directly use the one with x less than negative a less than x less than a? No, no, no. Why? Because we have x on the right side. It's not constant only. So you cannot use this definition. So you have to use the one with intersection. So that's why I always use the intersection one. How? You just copy the question 3x plus 1 without the absolute, 2x plus 1. Another one, because it's less, should be intersect. Another one should be 3x plus 1. So it will be more than the negative of 2x plus 5. Okay? Intersect, change direction, change the sign. That's all. Okay? So, this is what I'll always do. Okay, so if you want to put like this, we cannot eliminate the x here. So you have to separate, right? So I always use the intersection definition. But for this example, they want to separate and then do the intersection. It's okay too. Never mind. You can do that. Okay, it's not incorrect. It's true, but you need to do more step lah. So if you directly use the definition, you will get the same thing. So here you will get 3x plus 1 is more than negative 2x plus 5. Intersect with 3x plus 1 is less than 2x plus 5. And then solve for one inequality and another inequality. So we have 3x plus 1 more than negative 2x minus 5. So they used to skip. So it will be 3x plus 1 more than negative 2x minus 5. So 2x here will be 5x, and 1 here is -1, so -6. So x should be more than -6/5. And on the right side we have x is less than 5 minus 4 is 5 minus 1 is 4. So we have these two answers. Then don't forget this and is an operation between number set. So we have to find the intersection between these two answers. So draw down your number line. So -6/5 and 4, which one is smaller? Of course, the negative value. So draw the set on the number line. So we have x more than -6/5, so it should be to the right side. And x is less than 4, it should be to the left side. So the intersection, which is, yes, the in between these two value, the one with two line. Okay. So the answer, final answer in solution set, we have x such that x in between -6/5 and 4. Or you can write down in interval, it's from -6/5 to 4, open bracket. Okay? Okay, so let's do the last question, D. So, absolute 5x plus 2 is more than 2x minus 1. Okay, so directly by using the definition, so we have 5x plus 2 more than 2x minus 1, follow the question. Or, because it's more, it's or 5x plus 2 is less than negative of 2x minus 1. So solve for each of the inequality. So we have 3x minus 3. So x equal to -1. X is more than -1. Here we have -2x plus 1. So 7x less than -1. So x is less than -1/7. So because it's all, we have to find the union between these two inequality. So which one is smaller, -1 or -1/7? So -1/7 is like 0 point something, right? It's not, it's smaller at the value. But for the -1 is smaller than -1/7. If you are not sure about the value, you use your calculator. Because this one in fraction, right? So we don't know exactly the value. So use your calculator. Okay, so it's more than -1. It's less than -1/7. So the union, how about the union? Or is union, right? So we take everything. Everything we take. So the final answer should be, it's from -infinity up to infinity, which is x is every value in real number. So we can write down our answer as x such that x is the subset of real number. Or by using the interval form, we can write down as from -infinity up to infinity. Okay, so this is the answer for question D. So that's all for chapter 2. So we have two subtopics. The first one is inequality. The second one is absolute values, which include the absolute inequalities, the linear absolute inequalities. Okay, so that's all for chapter 2. Thank you.